Hi everyone. Today I'm going to explain my project which has the title of Analysis of BER in Multicast MIMO System with Spatial Modulation. Before getting into the topic, let us discuss about the four important terms that are very useful to understand the upcoming slides. First one is BER. BER stands for bit error rate, which is nothing but the rate at which the error occurs during the transmission of digital data. And then multicast. Multicast system is nothing but a system with a single transmitter connected to a multiple number of receivers for the conveniency, and also it simultaneously increases both the spectral efficiency and the energy efficiency. MIMO systems. MIMO stands for multiple input and multiple output. MIMO systems stands for multiple number of receivers and is connected to the multiple number of transmitters. Spatial modulation. Spatial modulation is nothing but a modulation technique which is being specifically moduled for MIMO systems. The main aim of our project is to analyze the bit error rate or spatial modulation aided multicast multiple input multiple output system and study the impact of bit error rate on signal to noise ratio, which is nothing but SNR. To improve the spectral efficiency and the energy efficiency of a wireless system, to increase the SNR of the input data stream, and so the BER is decreased automatically. To reduce the bit error rate for millimeter wave communication, this project is very essential. To analyze the BER in Rayleigh fading channel, this project is very authentic. The main aim of this project is to simultaneously exploit the amplitude and phase modulation and also to study the impact of bit error rate in Rayleigh and variable fading channels. Then coming on to the abstract, in this project, as we said, the bit error rate of the MIMO systems aided with a spatial modulation multicast system has been analyzed. And at last, the BER and SNR are plotted in a graph and their differences are discussed very well. At first, we will be measuring a burst receiver BER and then taking it as a reference one. And then we will be considering uncorrelated channel whose BER will be compared with the reference, which is nothing but a worst BER of the receiver, and then an upper bound will be notified. And then the second step is nothing but considering a correlated channel, and the same process is done, and at last we getting SNR degradation caused by receiver correlation, and then we will be exploiting the BER of the multicast SM type MIMO systems with the valid analysis. Introduction is nothing but all about why we are going for spatial modulation, and it is because of due to the over traffic in the modern generation wireless system, we'll be using a spatial modulation to improve the spectral efficiency and the bandwidth requirements at the same time. Literature surveys are nothing but they always meant that the previous technologies are only with them without any multicast systems, but the most important thing we have implemented in this project is a multicast system. And in this project we'll be having 7 modules, and each modules are displayed. And coming on to the first module, multicast SM type MIMO system. In this work, we consider the multicast MIMO system consisting of transmitter and K independent receiver. The transmitter is equipped with the anti-transmit antennas, and each receiver is equipped with the NR receiver antennas. The SM type MIMO is employed to convey information. In the multicast MIMO system, the information bits are processed by the spatial modulator for conversion to the SM type signals, which are transmitted in the next page and the next stage. Y of k is equals to root of rho h of k x of I plus n of k. H of k is nothing but a small scale fading channel, and rho is nothing but an average SNR, and y of k is the complex received signal for receiver k, and x of I stands for a complex transmitted SM type signal. And coming on to the next module, BER analysis for multicast SM type MIMO system with uncorrelated Rayleigh fading channel. In this section, we propose a BER upper bound for the multicast SM type MIMO system in uncorrelated Rayleigh fading channels. By exploiting the upper bound, the diversity of the system is elaborated. And here we consider the uncorrelated Rayleigh fading channel given by h of k is equals to h of k omega. H of k is nothing but a transfer function and omega is a standard uncorrelated Rayleigh fading channel. And then the next module is diversity analysis for systems with uncorrelated Rayleigh fading channel. As I've already mentioned in the abstract, we'll be considering a uncorrelated Rayleigh fading channel. What is uncorrelated Rayleigh fading channel? Uncorrelated is nothing but a group of channels with different characteristics are considered to be uncorrelated, and Rayleigh fading channels are nothing but those channels will explain the signal characteristics along with the environmental parameters. By this analysis, we'll be concluding the equation of E of rho E of L lesser than or equal to E of rho E is equals to maximum rho E of K. And coming on to the next module, we'll be considering a correlated Rayleigh fading channel. In this, the same analysis will be taken place and the equation will be displayed. And the upcoming slides are nothing but the explanation about the modules and how we are calculating those things. Coming on to the block diagram, this is a general block diagram which represents a multicast symbolically, in which the transmitter side consists of a single transmitter and the receiver side consists of multiple number of receivers. In the intermediate space, we'll be performing all those three steps. Like first, we'll be measuring the worst BER of a receiver, and then we'll be considering uncorrelated channel, and then we'll be considering a correlated channel, and we'll be analyzing the upper bound and the lower bound. And this is the general block diagram which represents the information bits is given to the spatial modulator, which is nothing but a transmitter, and it will modulate the waves into a spatially modulated signal and it gives equally to all the receivers. And this is the output between the BER and the SNR. BER comparisons between the multicast SM type system and conventional MIMO systems with NR is equals to 4, K is equals to 8. This is the same thing but the uncorrelated output with NR is equals to 2, 4, M is equals to 4 and K is equals to 8, 15, NT is equals to 4 and NA is equals to 2. Hereby I've been concluding that advantages of this project is mainly that BER will be automatically low, as along with that SNR is automatically high and it reduces the transceiver complexity due to the presence of multicast systems, and SM type MIMO system advantages over the conventional MIMO type energy efficiency design aiming to maximize the energy efficiency. And these are the hardware and software requirements. And coming on to the